Any questions? Again, just a reminder, I said it at the top of the class, I'll say it again, and I'll say it at the bottom of the class. I will be in the studio at Triton College, room G304, this Thursday between 5 and 6:45 p.m. Anyone who missed the midterm, please send me an email. Let me know that you're going to be there so I know to be there. If you want to retake the test, take the midterm, you're welcome to do that as well. But you have to let me know. Send me an email. Tell me that you will be there so I know to be there for you. I don't want to take an Uber out to Triton College and have nobody show up, right? That's not a good use of my time. So if you're planning to take or retake, you got to let me know via email by noon on Thursday so I know what's going on. Make sense? Thank you, Olivia. Yes, your time is important. My time is important as well, right? That's the one resource we never seem to have enough of is time. So we need to manage things carefully, right? I want to have time with my friends and family just like you do. Okay, so we're talking about structural steel, right? Commercial buildings we can build out of reinforced concrete, either cast in place or precast. We can also build commercial buildings out of structural steel, right? We have a wide variety of shapes and sizes of structural steel that can be utilized as the parts and pieces to put the building together. Yes, I'm hearing someone's. You have a question, Patrick?
No, sorry, I just had it on auto.
No worries. So again, similar terminology, whether we're building in wood or concrete or steel with beams and girders and columns. We also have trusses in residential wood construction. So the terminology is the same. The concept of what we're trying to do is the same, right? We're trying to transfer loads from a floor or a roof to a column down to the soil or whatever we're bearing upon. But we can do that same thing in wood or concrete or steel or some combination thereof. Right, we have different shapes of structural steel. Right, again, this is from I think from Unit 7. Right, we have our W, a wide flange. Right, we have the web and the flange. Right, the flange is this guy on the top and the bottom. The web is what's in the middle. W describes the shape. And W21 by 147 is the depth and the weight of that steel. So again, different shapes will have different properties, and the structural engineer will be aware of those properties and know how to design accordingly. Yes, Nicole.
Okay, so the wide flange shape, it's a W shape, but the picture doesn't look like a W. It still looks like an I.
Yes, that's correct. It's a yes, why they call it a W and an M and an S. They're still the common term that I'm used to is an I-beam, but those I-beams can come in a couple different shapes.
Okay.
Why they called that particular shape a W, I think it's because it's a wide flange. But yes, it is a little confusing because all three of these things, the S and the M and the W, all look like an I, but it has to do with the width of that flange on top. And then each of those beams is going to have different properties as well.
Okay.
Properties would be, you know, their ability to span under a certain load.
So
I think
if you say I-beam, it could really be a W, M, or an S.
That's correct. Yes,
Okay.
a steel I-beam could be any one of those shapes. So I-beam is generic. If you want to be specific, you would have to say exactly what it is, an S, an M, or a W.
Got it.
Okay. Again, more structural steel shapes. Again, I think we picked this out of Unit 7. T's, Z's, L's, right? Different shapes. Right, so here's some examples. Our W12 by 16, a wide flange beam, 12 inches deep, weighing 16 pounds per linear foot. Or an angle L3, 3 by 3 by half, right? 3-inch long legs, ½ inch thick. Again, each of those will have different uses and different properties. Right, so again, here's our three-dimensional lattice of steel members, right? Just like we talked about with concrete. Floor loads are transferred to beams. Beam load is transferred to the column. Column load is bared down to the footing or the foundation. The footing or foundation is bearing on soil or bedrock, depending on what we're doing. So again, we want the building to hold itself up and to bear the weight of whatever we want to put in it. So we need to transfer loads down to a firm foundation. You see some pictures on page figure 11-22 on page 199 of open web steel joists. Right, so these are things that are used in either floor or roof structures. Again, I think we saw when we were looking at Delhi wall detail, we saw a open web steel joist bearing on that concrete block wall. And this says supports loads more efficiently than wide flange beams. What that generally means is that we're using less material. We're supporting the same load with less steel, less weight, less cost. And those joists can either be top bearing or bottom bearing. We'll see what that means in a minute. It means that either the top member or the bottom member is what gets connected to the supporting column. Again, here, yeah, this is figure 11-22 in the book, right? Top bearing, right? This would be the part of the beam that bears on structure, the top of the top member, as opposed to this guy where the bottom, or this joist where the bottom member is bearing on structure. So this is a top bearing or a bottom bearing. And you also see from here that the joists also have pitch to them, right? Who remembers why we had pitch in the roof joist in Delhi, right? We looked at we were probably looking at something like this, a top bearing joist. Why would we have pitch in a roof joist? Well, we have pitch in a roof joist to give pitch to the roof structure to convey the water away, right? Remember when you looked at Delhi, we had a pitched roof joist going to scuppers along that wall. I forgot which direction it is, but yeah, that's why there would be pitch in a open web joist. Obviously, if this is being used for a floor, we're not going to have pitch in our steel joist that's supporting a floor, but we are going to have pitch in that joist if it's on the roof. So again, pitch or no pitch, top bearing or bottom bearing. Right, so here's an example of, this would be a top bearing steel joist made up of different members that are welded together, right? This is done in a shop or in a factory. So this member would come out on a truck and get lifted up by a crane, would be erected. Right, here's another example of again, a top bearing steel joist, in this case bearing on a I-beam of some sort, Nicole, whether that's an S, an M, or a W, I'd have to look up. But again, here's a top bearing open web steel joist.
On the other picture, back one more. So you see where it says in bearing member?
Yes.
Yeah, it appears that you have the I-beam, but then coming like perpendicular to that is
Something else. Yeah, I think in this case this plate here would actually be bearing on something else. So it'd be bearing on the I-beam, or it would be bearing on right, in the case of that detail for Delhi, I think we had a bearing plate on a bond beam. So this thing at the end here would be what would come off the back of the truck with the joist, and then it would be bearing on something else. It would be transferring its weight to something else.
So, but it's already, because it's prefabricated in the factory, that plate is already connected to the I-beam with that sort of perpendicular piece that's going right behind
Yes.
like a bar.
Yes, yeah, I'm guessing this is prefabricated, and this N gives it the characteristics that the designer was looking for, right? The ability to transfer this load to this point here.
Okay. So it's not a separate piece, I guess, is what I'm asking.
No, I believe it's all one prefabricated member.
Okay.
Yeah, if you go to engineering school, then you would learn about this, and you have to do calculations about which of these members are in compression and which are in tension. So Yeah, a lot of complicated stuff if you want to be a structural engineer. Otherwise, as an architect, in all likelihood, you're going to either go to your structural engineer or you'll look in a table that says this particular steel shape has these characteristics. It'll bear this load at this spacing, at this length, just like we would do if it was a piece of wood, right? Conceptually, it's the same thing. You know, it bears a certain load with a certain center to center spacing with a certain span. The concepts don't change, it's just the materials that change. Right, so here's an example of, right, these would be top bearing open web joists, in this case, bearing on this steel member here, right, probably in some kind of I-beam. Right, we have different designations of those open web joists, right? K, LH, or DLH, depending on the span. How does this get put together? Things can get put together with either welding or bolting. Right, again, we have different steel members that all have to be assembled together and held rigidly in place. Here's some examples on, we're now on the bottom, figure 11-23 on the bottom of page 199. Right, you see how these pieces are coming together right in wall section L. You see the K joist bearing on this W section beam, and leaning up against this precast wall panel. And on top of the K joist, we have a steel deck with concrete that's poured on top. This obviously it looks like it's this top of mezzanine floor, so this would be a system that's giving us a floor. This one here looks, this section 1 looks similar to what we saw for Delhi, right? We have a we have a top bearing joist that's bearing on a concrete block wall, right? So we have a steel bearing plate that's bolted into, that's anchored into the concrete here, and that's what the joist bears on. And on top of that is a metal roof deck, right? This funny symbol here, which we'll learn about in a couple of weeks, right? It indicates the welding that takes place. I'm going to really struggle to explain welding symbols. I actually have a video that I'll show for you that explains how to interpret that welding symbol. Right, so here's metal decking, like metal decking used in combination of open web joists and concrete. Again, this is going to be a typical structural system in a steel building, right, where we still have this thin concrete floor slab that's poured on top of the steel deck that's supported by the open web joists that are bearing on this steel I-beam, which ultimately bears or is bolted or welded to a column, right? Here's a picture of pouring a concrete floor slab over metal decking, and you can kind of make out the welded wire fabric here, the reinforcement. So there is some reinforcement in this concrete slab. Again, another potential way that the parts and pieces get put together. Right, here's the bond beam up on top. And we have a piece of angle bolted to that bond beam that the metal deck bears upon in one direction. Here's Nicole, here's that, you can kind of picture that same bearing plate on your open web, on your top bearing open web joist. Right, another typical detail. Another picture again, open web joist, metal decking, bearing on a steel beam, which bears on a column. Okay. Let's do this. First of all, any questions?
On figure 1123.
Yes.
What is that EQ on section B? What does that EQ stand for? It looks like it was referring to the CMU blocks, but I'm not
Yes.
sure.
Yeah, I think they're saying equal. So the way I would interpret that to mean is that the number 4 rebar, right? It says number 12 CMU with. Let me go back to that picture so everyone else can see. Right, we have this piece of number 4 rebar running vertically. I'm thinking this means that it has to be spaced equally, has to be smack in the middle. That's what equal, EQ period equal. Right, whatever this dimension is here, we're dividing it in half. We're putting that number 4 rebar smack in the middle.
Got it.
Again, the art and the science of building is advancing, right? We're holding up loads with less and less material, right? We're trying to get the material out of our buildings through all these different techniques, right? Materials add cost. Materials add embodied energy. We're trying to get both of those things out of our buildings. But obviously we have to, as the designers, have to think carefully about what we're doing. And as all the tradespeople who are executing this, we have to execute according to plan to achieve the result that the designer was looking for. Okay, any other questions? Okay, we have, let's do this. I'm going to divide you up into teams, and we're going to go back. This is activity 11-1. We'll spend maybe 15 minutes on it, so we won't get all the way, we might get 6 or 7 questions that you guys have a chance to work through. So let's do that. And then I will bring you back here at, geez, you don't have much time here. We'll spend about 10 or 12 minutes starting to get into activity 11-1, and then we'll finish it up at the beginning of Thursday's class. So hopefully you have our old friend sheets from Delhi, except now we're going to be in the structural sheets. So this will be Del 16 to Del 22. So let's do that, and we'll get back together here in 15 minutes or so and see how much progress we've made. So let me push the button, and please participate. I know it's hard when we're all virtual, that some of you can not be putting in the effort. It's hard for me to know who's doing what. But come midterm time, then it becomes more apparent who's putting in the effort and who is not. I realize that this is complicated material. I'm doing my best that I possibly can to explain it to you, but it takes effort on your part to learn as well. We have to meet in the middle, right? I do work and you have to do work as well. Okay, enough of that. Let me break you out into groups here. Let me see how many folks we have here. We have got 17.